oh, wait, hang on, we liked occlusion culling. What's the go with that? It's worth noting that nanite sort of has this like non-zero cost associated with it when it comes to occlusion. It's not going into the CPU draw occlusion cull, right? And that actually means that if you are using only nanite geometry, you can actually turn off the ability to do CPU draw culling. Just turn it off. You don't need it in these scenarios if you're only using nanite, because you're not going to get any bonus from it. This is especially important in projects that have multiple viewports, ICVFX, because the way it happens in ICVFX now, going to change, but for now, is that we can process on multiple GPUs, right? We can have 2 GPUs in there, one showed us, but our CPU draw actually happens sequentially for each viewport, which means that in these environments, our draw thread is working sequentially, and we can really start to run into problems, reducing the amount of draw calls we can actually do. So a good way to do that is to turn off that off. But here's the other rule that I want you to think about. Nanite can include nanite, which means the more you nanite, the better you're going to nanite. All right? And so what I mean is that if you have a CPU mesh and a nanite mesh behind it, you're going to draw both, okay? Because the occlusion cull is separate. But if you have a nanite wall and then another nanite mesh occluded, that nanite is going to block the nanite behind it. So we like nanite stacking up. And the biggest example of this is implementing nanite to work on landscapes. Okay, yeah, we can have higher quality landscapes potentially. Who cares? The best thing is that landscapes are typically our biggest occluder in the scene, right? So we're able to do more occlusion in our nanite paths. Cool, so I can use it everywhere. Well, not quite. So nanite is currently limited to rigid meshes, and this represents something like 90% of the geometry that's going to be in a typical scene, so pretty good. Nanite supports dynamic translation, rotation, non-uniform scale, rigid meshes, but it does not support general mesh deformation. So no one's allowed to ask me during this presentation if nanite's going to work on your skeletal meshes. That question is forbidden. So I know some of you want to ask it. Wow, we're not answering that. Doesn't work. Okay. One of the things that I do want to cover though is that vertex painting on instances is kind of not supported in a way. It kind of is. It's a bit different. Okay. So our vertex data that we might put into an object can be in a nanite mesh, but because of the way we batch render the nanite meshes, we're not able to have unique vertex information. So where we might paint vertex data into a mesh to apply moss or something to it, nanite is going to use non-unique information. So every nanite mesh will have that painted in. And we still support vertex data, but not like in a non-uniform way. So you can do some really cool things with this. For example, I'm going to find a rock, and I'm like, this rock looks good, and I download it, and then I add it using Quixel. Just love that. It's so good. I put it in my scene. I cover my rock that I was going to do, then I decided you all deserved a bigger rock, so now it's being occluded. I set the time of day because, come on, gotta be nice. But what I want to show you is we go into our geometry tools. We go into modeling. We're actually able to bake inside the engine. Who knew that Unreal Engine had a baker tool? How cool. 2 people down there. 3, yeah. This is super cool, right? So we're able to do a bake straight to the vertex data, and we're able to specify what channels we'd like to bake. And we can do this across RGB, or we can separate those channels and do like a texture pack, essentially. And in this example, I'm gonna bake curvature data to that mesh. And what's cool about that is then I can use that to put bits of snow in the cracks or all these kind of dynamic things, right? Or I could put the AO mask in there instead of using a really expensive texture, okay? And so I can use that vertex information for stuff. And it's worth noting, because of the density of nanite meshes, this actually works really well. This is an old school technique, right? Putting information in vertex data. It's a thing that we thought we'd never go back to, but we have, because our meshes are so dense that we get really good outcomes. So that's kind of supported. But also, well-positioned offsets. This is something that was communicated early on that would not be supported. Note the double asterisks though. And the reason for that is we go to the friendly documentation page. It's possible that and we come down and we're gonna see beta feature well-positioned offset in materials, okay? So this is supported in a beta kind of format, right? Am I communicating clearly? You've been warned, but I know you're all going to do it anyway because it's awesome. And so let's look at what best practice might look like, okay? So here we have our trees. They're static meshes, but we're applying the well-positioned offset. We're applying vertex shader to essentially move those trees, okay? And this means it's going to have huge costs, not only because there's all those polys, but also it's going to affect our VSMs. So if we go ahead and put in well-positioned offset disable distance, we can actually stop well-positioned offset at a distance where it doesn't matter. See how it's popping though? And that looks kind of ugly when we go through this transition. Let me show you a little trick. Oh, I just see that my chat, oh no, all good on the chat. So we open up the material. Did we go back in time? We did. Forward in time. So if I open up the material, what we've got is essentially the wind thing going into the well-positioned offset. And if I apply a simple node that takes the camera position relative to the object's position or the pixel's position, and say divide that by 2000 in this case, because that's what we're toning it off by, effectively what we're doing, and then lerp that information in. So the further away we are, the less wind is going to be applied. And at 2000, we're applying no wind. What's going to happen is that the further away we get, the less wind, right? And what that means is as we move out, we slow down and we don't see the pop. It's a really good way to handle that, okay? But you remember what we learned about VSMs? This also applies. So we're invalidating those pages, pop. Right? It's all coming together. Because I bet you're all like, how do we not do movement? Jack, you're insane. This is the good stuff. So you're like, I'm sold. How do I turn on nanite? Well, we actually turned a tool that can brute force turn on nanite for you because you're going to want to do that. In this tool, you've got two different things. You've got errors, which are all the meshes for whatever support reason it's not going to work on that you could explore. Then in optimize, you can give it an amount of tries that you want to look at. You might say 10, and it will go through and apply nanite to all the meshes that will support this. Okay, so nanite. We're feeling good about that. We understand the implications with how everything works. We're very excited by the technology. Let's talk about Lumen. Now, we've actually covered some of this content, so I'm going to be sparse on some of the slides. But essentially, I wanted to start really simply by repeating something because I see a lot of confusion about this specifically. And that is, people say, oh, is Lumen to do with shadows? Like, what's the, because, you know, VSMs came out at the same time as Lumen. And I think that people got a little confused about how they relate. Well, Lumen is only applying to previously what we called SSGI, screen space global illumination, distance field ambient occlusion, and screen space reflection. And it's upgrading them with Lumen, okay? And Malachi did a great breakdown of this. So as I said, I'm not going to go into a lot of depth, but to turn it on, we come here and we're going to make our first sort of decision that we're going to have to deal with. And the core of this decision is kind of, are we going to use hardware ray tracing? Are we going to use software ray tracing? Okay. And so in general, hardware ray tracing is more expensive, but it's going to work. It's going to give you a detailed trace more effectively than software. And I'll dive into this. But if you're using hardware ray tracing on console, what we're saying is it's kind of, you're targeting that 30 FPS rather than that 60 FPS. okay? So in the context of console, then software medium is your 60 FPS kind of target. Just to give you some vague, just just to pull things out of the air a little bit. Obviously your project comes into play, but I think sometimes just pinning some loose numbers can be useful. So Lumen, we've learned a lot about this, but we know that we get the free kind of lights from the emissive from final gather pass. Something that really does depend on, so Lumen doesn't work with static lighting. So you may as well turn static lighting off. The reason you do this is when you turn static lighting off in Unreal, you get access to some cool new things, some new toys, right? And the biggest one is that you're able to use material ambient occlusion. So when you turn static lighting off, which doesn't even work if you're using Lumen, you get access to put information into, that grayed out material ambient occlusion channel in your materials? Suddenly you can access that, okay? And this can have some pretty high improvements to fidelity, right? That you could have on your meshes. The other thing that it'll allow you to do is to support bent normal maps, which are going to be more expensive, but they're also going to improve fidelity again. Okay. So to support bent normal maps, you do need to put that in your default INI. It's not on by default. I think we got a really good breakdown from Malachi's talk, but in relation to performance, it's worth noting that that these things do. This is a good place to start in terms of optimization. And the thing I want to say is obviously that all of these things are going to have an impact. So Malachi showed us the hat, and obviously if we're culling smaller objects from the Lumen scene, we're going to be optimizing things, right? So you want to get these things down as much as possible. Improving Lumen scene lighting can, decrease artifacts. So you're constantly going to be playing versus your feature budget and your performance budget. Okay. View distance, right? Do we want to calculate Lumen on everything? It's a bit like looking at our shadow paths. And if we don't have to, why would we? Sorry, that's the Lumen scene detail. That was the hat example. But let's just sort of burn through these. Lighting update speed is this is effective when you want to do like the, I don't know, like in Dungeons and Dragons or some fantasy game where you go camping and the sun's going to go woo, woo, and it goes back to the next day, a big time of day cycle. You might want to think about updating your lumen speed to get rid of those artifacts. But when you're done, you can slow it back down. So it's directly related to your scene. And you can think about this shot to shot, environment to environment, task by task. That's the way you should be thinking about it in regards to performance here. So a big thing here is that we've really simplified how we can conceptualize Lumen, and that's been really helpful because rather than explain all the differences in performance and what they do, they're actually to scale to those default settings in your editor that you can turn on, and you can say, okay, I'm going to work in medium and I'm going to render in cinematic, and we're going to get two different outputs, right? So that's really useful. So cinematics quality is for movie render queue. Epic is for console budgets of 30 FPS. High is kind of the console budget of 60 FPS. And low and medium scalability start to disable Lumen's features progressively. Remember, Lumen's doing quite a lot of things, so we can kind of step it down in small amounts. Let's talk about medium though, because that's where we start talking about what's going to be turned off. So large scale ambient occlusion is going to use distance fields. Distance field ambient occlusion instead. We're not going to use Lumen's ambient occlusion. Distance field ambient occlusion still looks pretty good though, right? So could be all right. And for small scale ambient occlusion, we use screen space ambient occlusion instead. Okay, so we're using those kind of pretty clever together. For low quality, we're only using it on unshadowed skylights. We're going to be adding to the Lumen scene, all right? So only that skylight that's everywhere is kind of adding that that feeling. If you want to see how that you can scale this on different projects, Lyra is actually set up with this. So Lyra is a content example, and it was designed to be published to mobile, to, like high-end console, etc. And so you can look at all the INI features and look at how they're actually handling Lumen at a scale in a project like that. That's really useful. Of course, there is a difference between software and hardware ray tracing that I've covered a little bit. So software ray tracing is basically the fastest method of Lumen, and that's what we're recommending for 60 FPS games. But when you go to software epic scalability, you are activating something called detailed traces. And these traces provide much higher quality, but they incur a large performance overhead. So basically the difference with detailed traces is that they happen against individual mesh distance fields. And this makes performance sensitive to the number of instances and the number of overlapping instances of those global distance fields. Of those distance fields. If we're not using detailed traces, then we're using a global distance field, which treats all those meshes like one big field, and it's going to lower the fidelity significantly. So this can really start to add up if we're using lots of kit bashed assets and we're not using things like asset merge. But you need to be careful because you need to account for the quality of your distance field. And Malachi actually showed some examples of what happens when we have these big convex complex hulls. We end up with leaks, right? So we can disable effects distance field lightings on individual meshes to actually remove them from that detailed trace. And we might be able to do that on certain meshes, big meshes that aren't really adding a lot of value. That's an artistic choice. But I suppose the big point here is hardware ray tracing is going to outperform this and high detail level, right? So we're looking at software ray tracing at that detail level trace. Hardware ray tracing with GPU acceleration is going to do a better job. It's going to do it more efficiently, okay? So high levels, so at Lumen at high level, we're actually disabling that detailed trace. It's only really at that epic and cinematic level. It's worth noting though, we're using different render pipelines. So when you're going in, you're working at medium quality. Just be aware when you render at cinematic, you're going to have a different, well, it's going to be better. I mean, that's kind of assumed. So hardware ray tracing provides Lumen with improved quality, and we recommend it for games on consoles targeting 30 FPS. I know that this is an animation conference. I think that these numbers kind of help once again. But this cost is proportional to the number of instances you need to include in this accelerated structure. So achieving 30 FPS on next generation console ideally means having fewer than 100,000 instances in your ray trace scene. All right, and that's why I say you can actually take things away from your ray trace scene. You can identify this by using stat scene rendering, and it'll actually give you the amount of instances. And so we're kind of okay in this scene, right? We've got a budget of about 100,000. So how do we reduce this? Well, there's a few different ways. The easiest is using far field to provide a really quite aggressive culling without compromising the global illumination or reflection distances. So look at far fields probably as your very first port of call with hardware ray tracing. Obviously, this is a pretty complex thing. So I'm going to give you another QR code. This was published really recently and does an excellent job of breaking down all the performance nuances of Lumen. So you do have a little bit more reading to go, but I would encourage you to if you are going to be really trying to ship Lumen at a high quality, then you really need to be across this stuff. Once again, this page is so good. It's really high quality and very easy to digest. The final thing we're talking about today, so we've made it almost, is profiling tools. Profiling tools, if these are the techniques, if the techniques are your right hand, then profiling is your left hand, okay? Because basically we need to work out what the hell's going wrong. And I'm gonna give you my abridged version of profiling, because profiling is a big subject. But we've already introduced our first step, which is the GPU analyzer. Now, the best thing about the GPU analyzer is that you can open it with a hotkey and it just opens and you can see it, which means it's always there for you. It's your friend. It's like your little demon on your shoulder. So the best thing about it is its convenience, honestly. It's also a really good tool, but it's right there. And so all you need to do is press Control-Shift, comma, and it will tell you what the GPU is doing at any point. It'll tell you the duration of any of these things. We know that the green one here is the shadow depth, but we're spending the most effort on diffused, I can't read that, indirect AO, right? What do I do with this, Jack? Okay, I've got this thing that says my shadow depth is like huge. Well, firstly, don't panic, because you don't know what each one of these things in the renderer is. Google it. I'm serious. This is how you learn profiling. How much should things cost? Don't worry. As you work with profiling, you'll kind of get a sense of this. Don't avoid it just because it's scary. Just try. And so if you've got heaps of shadow depth, if you Google the word shadow depth, the first thing it's going to tell you is what I told you today. So even if you forget everything I said, it's going to say your vertex count plus your attenuation volumes is killing you. And you go, okay, I'll just fix that, right? With the techniques that I showed you, right? So it's okay not to, it is a process of a million paper cuts sometimes, and it is going into each of those things, Googling it, working it out, not panicking, just kind of exploring, keeping an eye on it as well, and working out what values we want. Ideally, all these equal 0, but that's not reality, right? And this is why I say that features have a cost. You might optimize the hell out of Lumen, but only get it so far to your overall outcome. And you say, well, Lumen's going to be at 5 milliseconds, and we just got to accept it. That's what we're doing with our scene. We're going to have to find performance from somewhere else. And that's why I say that optimization is a creative process, because we're moving the balance around. It's not about one of these things being 0. It's about the total sum of all of them together. All right? The next one I want to point out that's really useful in UE5 is if you download RenderDocs from render.org, this one's going to scare you. And I'm here to tell you that's okay. So RenderDocs is really awesome because it's a free plugin, ships with the editor, the plugin does. You download RenderDocs on the side. What RenderDocs is, let's just have a look at how easy this is to turn on before I explain why. So I go into type RenderDocs, I tick yes, please. It's going to restart the editor.
Timeout browser restriction it seems.
नेटवर्क चले गया वाईफाई बंद किए लोग
They turn on the
Give me a second.
sir?
5297, 5297. Press 5. Press 5. Yeah, we're still recording.
And you'll see up here, this is actually when it actually kicks in. And we can see we've got some frames. And your favorite key is the F key. So if you select up here, you'll see the overall performance of all your threads. Click F, and it will zoom in to the start of a frame and an end of a frame and show you where that is. Because that's typically what we're looking for. We're looking for a frame of information, right? And you'll see that we start in the game thread. If you look carefully, we pass it to the draw thread, and finally it goes to the GPU thread, and we can see the relationship of all those things. So it's a bit like profile GPU from before, but we're looking at everything. And yeah, this is overwhelming. But once again, my advice to you is to not get afraid. Just kind of look at it, explore it, use the F key, your favorite key. Remember it like that. It'll show you the frame, and it will show you the outliers that then you go Google. That's the process. That's all it is. That's the beginning of profiling. And with that, we made it, everyone. Well done to all of you. I think we're not quite done. However, though, we want to give one more opportunity to do some Q&A. I might just answer some questions on this topic for about 5 minutes or so. And then after that, we're going to get all the other technicians, Epic stuff, I don't know, all the rest of the people wearing the Epic shirts on stage, and we'll just answer any other questions that you have milling around your head. But yeah, let's throw it open to the crowd. I'll check. There's nothing in the Q&A right now. It's okay. That was a lot of content as well. If we're just absorbing, we don't have questions. That's fine. Any questions? Going once. Going twice.
I got a somewhat specific question about the proxy merge.
Yep.
Sometimes I do that and the materials shoot out all pink. The textures, actually, I think it's
that could be because of a support level feature during the bake. In the new bake, it's using certain material effects that aren't actually supported in that bake, so it's unable to atlas it in any way because it can't get that. I think, what are the common operators that do that? Yeah. Yeah. Yeah, that's a big one. WP, just to repeat for the online people, Chris Murphy just said that commonly something like well position in that bake won't be picked up because it's not expecting it from that perspective. Sorry, do you want to just repeat that?
Yeah, I mean, I don't know exactly what your problem is because it's a little bit of a please check out my forum post question, but my gut feeling says it would be something with a vertex interpolator, or so you'd want to look for something that's passing through your vertex shader back into your pixel shader, which means either look for a vertex interpolator nodes or look for the custom UVs node and maybe see if something is within those. It's purely a shot in the dark, but that would be the first thing that I would check. I'd also make sure that all of the shading models are boring, because I'm not sure what the merge does when you're feeding in like cloth or fuzz and such. But again, it's a total shot in the dark, so sorry about that.
Any other optimization questions, or are we happy to? I think let's move along.
వైఫై ఆఫ్ చేసిరా మళ్ళీ ఎవరు టామా
తిన్నాక వేసుకోవాలి ట్యాబ్లెట్ తెలుస్తుంది వేసుకోవాలి.
The recording has stopped. ఇవాళ 2000 ప్రాఫిట్. నేను ఆటోమేటిక్ పెట్టనే లేను ఇంకా. నేను రాత్రి ఒక గేమ్ ఒక చిన్న ఎక్స్పెరిమెంట్ కొట్టిన దానివల్ల వచ్చింది. చిన్న ఎక్స్పెరిమెంట్ ఏదో అకౌంట్ చూద్దాం ఏమవుతుంది చూద్దాం వర్కౌట్ పిల్లలకి ట్రాన్స్పోర్టేషన్ ప్రైవేట్
వస్తున్నారా మరి మీరు
నేను యాక్చువల్గా రేపు పోయిన తర్వాత రేపే ఎడికైనా తీసుకెళ్ళిపోతాను బెంగళూరు ఊటీ లేకుంటే సంతది నిజంగా చెప్తాను సంతది రేపు సాటర్డే కదా
Ended.
ఇట్స్ సండే స్టాప్ రికార్డింగ్
it stopped recording. It may sound that one.